Andrew, a package management nerd, and I've been working in the space of trying to understand and extract data from open source projects to help with solving loads of different problems around trying to understand them and how to best enable and improve open source software for quite a few years. Work out what the impact of open source is and like what is the reason to do this kind of analysis. So there's lots of different challenges involved in studying open source software, but that in kind of attacking those challenges, you then start to unlock some interesting abilities. Ultimately, what I'm trying to get to is that if we have good data, we can then use that data to make good decisions, which then can improve open source software. And because everyone uses open source software in all their software, that ultimately improves all software, which can ultimately improve the world, right? That would be a really good thing to have. Lots of challenges. So as soon as you start going to look at open source data, you realize that every different software ecosystem has different formats, different files, different names for every kind of piece of metadata, even though it's all pretty similar. Every dependency network is ultimately the same within each programming community. They just use different formats and different ways of describing them. If you can have a system that can work for everything, then you can build tools that work for every community without having to understand each one of those communities necessarily. I've built a system called Ecosyste.ms, and it basically gives you a normalized layer of metadata for software packages and repositories, and then everything that goes along with that. And it collects data from something like, I think it's 35 now, software package managers, normalizing that data out so that it is in one standardized format, and then hundreds of millions of open source repositories from GitHub, GitLab, Bitbucket, Codeberg, and hundreds of other smaller forges as well. Just to give you an idea of some of the numbers, the database is about 12 terabytes, with about 1 terabyte of just indexes to be able to query that on a fairly performant basis. And all of this is available to download. Absolutely crazy numbers that are happening in open source, and it's literally the growth of every ecosystem is accelerating right now. What kind of things can you do with it? Well, you can find critical open source projects within a community. You can go and discover who the key maintainers are for any particular software ecosystem or for all software ecosystems. And then you can also connect this data to other kinds of networks. So I've got a few little case studies where things of this data has been used to enable new and interesting analysis. One way is looking at software paper mentions, and you get some absolutely crazy visualizations. It's probably really hard to read on this screen, but there's a lot of links between papers that you don't normally see. And this worked for 3 different kind of package managers: Python, Bioconductor, and R, all with the same code. So we were able to put this together in 2-day hackathon, which was enabled by the kind of the normalization data that I had already put together. Another example, I've linked to the slide here of Josh Bressers, who does a security kind of analysis of all of open source. And he's kind of blown away by how many versions, 100 million versions of packages have been published, which is, if you were to try and review every version of every piece of software that's being published right now, you're never going to be able to keep up because there's more and more every day. The graph on the right looks like it's broken, but it's not. It's just absolutely shrunk. So this is the number of maintainers that exist on packages. Basically, most packages, most open source software only have 1 maintainer, which is a really scary number when you look at how many people depend on all of these things. And that graph there is like, oh, there's nothing there. It's because it's literally just one tiny axis on the right. Another thing I did is I looked for funding data. I wanted to find out which projects describe how to fund them. I mined the funding YAML files across all packages, and as well as GitHub sponsors data, and if some package managers have metadata around funding links as well. And I found some interesting numbers there. So you've got like only 22% of critical, which is kind of like, you know, the top 10,000 open source libraries have some kind of way of describing here's how you fund my work, which is a tiny amount really, considering how all you need to do is to drop some file into your repository that says here's how to fund this thing. And the top 1%, which is, you know, like, what's that, 100,000 projects, is only 14%. I'm also working with Open Collective at the moment to try and connect the dots between funding data and activity data on open source projects. It's an ongoing project, but to give you a kind of an example, we can look at financial data of the projects, how much money they receive and how much money they spend, and then compare that to the activity data on the project. So do they get more contributors when they receive or spend more money? Is this kind of data then, because Open Collective supports all kinds of different projects, I was able to just normalize that out and go, okay, well, here's generalized activity data for all these projects, and we have generalized funding data for all these projects. What are the trends there? Eventually, we'd like to get to the point where anyone can just dump an SBOM in there, here's all my dependencies, and have Open Collective be able to say, well, here is this financial state of all the projects that you're using in your application, be it open source or closed source. Some things I got on the roadmap are doing really in-depth license analysis, looking at more security data. The OpenSSF scorecards, a prime example of like trying to understand the best practices around CI and different kinds of security methods that people are taking in maintaining their software. So yeah, thanks very much for listening.